Hello students, I am teacher Anis. I welcome you to today's lesson. We are still looking at the Form 3 Chemistry, the chapter 2, known as the mole. And in our previous lesson, we have been looking at the molar solutions, and we looked at two terms, that is molarity and concentration. That was under molar solution. So we saw what is a molar solution, and today we are going to prepare molar solutions. So this is part 6 of the chapter, and we are looking at preparation of molar solutions. So first we start by reminding ourselves what was a molar solution. So how did we define molar solution? So we said molar solution is a solution that contains 1 mole of a solute per liter of solution. So that is what we refer to as molar solutions, and we are going to prepare these solutions, and the apparatus that we are going to require in our lab are the volumetric flask. This could be a 250 centimeters cubed volumetric flask, a 500 centimeters cubed, or a 1000 or a 1 liter volumetric flask. Then we are going to use the wash bottles or the teat dropper. Then we are also going to use the measuring cylinders, also of different sizes. So let us get to the preparation, and we are going to start by looking at the steps that are followed during the preparation of molar solutions. That means any molar solutions must follow. As we prepare molar solutions, we must follow these 5 steps. So the first step is to determine the number of moles of the solute needed using the desired molarity and volume of the solution. So most of the cases we are usually given the molarity of the required solution and the volume of the solution. So we have first to determine the molarity of the solution we are going to prepare and the volume, so the amount of the solution we are going to prepare. So that must be given. So that one will help us to determine the number of moles of the solution of the solute that is going to be used to make this or to prepare this solution. And we are going to use the formula molarity is equals to moles times the volume in liters. So by using that formula, and we have molarity and the volume, whether in liters or not in liters, we should first change the volume into liters. So we are going just to multiply molarity by volume to get the number of moles. The second step is to calculate the mass of the solute required using its molar mass. So now we have the number of moles from the first step. So in the second step, now we are required to determine the mass. So we have the mass, the moles, and the molar mass. So for example, if we are using sodium hydroxide, we can get the molar mass of sodium hydroxide, and then using the formula number of moles is equals to mass over the molar mass, then we can find the number of mass, the mass number, or the mass of the solute required by just using the formula moles times the molar mass. Then step number 3, we are going to dissolve now the calculated mass. So from step 2, we got the mass. So we are going to dissolve this mass of the solute in a suitable solvent. And in this case, we usually use the distilled water. And we dissolve this mass in a beaker. Then we use a stirring rod to stir this solute to dissolve in this distilled water to form a solution. Okay, so that is step number 3. we dissolve the calculated mass of the solute in a suitable solvent, or simply say dissolve the calculated mass of the solute in distilled water in a beaker, then stir to dissolve. Step number 4, we are going to transfer this solution into a volumetric flask. Depending on the volume we are required to make or to prepare, that one will determine the size of the volumetric flask we are going to use. Then, after transferring the solution into a volumetric flask, we are going to rinse the beaker with distilled water still, then transfer the content. So that water that may be containing the solute, we are going to transfer it now to the volumetric flask where we had put the solution again. So that is step number 4. Step number 5, we add distilled water to make up to the desired value. Then if we are using a 250 centimeters cubed volumetric flask, we are going to add distilled water up to the mark to ensure that we have prepared a solution up to with a volume of 250 centimeters cubed. So we add distilled water to make up to the desired value, ensuring thorough mixing to obtain a homogeneous solution. So as we add distilled water, we can mix, we can shake, or that is, we can stir to ensure that the solution being formed is a homogeneous solution. So we add distilled water and make sure that the components are mixing properly to form a homogeneous solution. So these are the 5 steps that we are going to apply when we are preparing any molar solution. So the differences now will just be the molarity and the volume needed to make the solutions that we are going to look to prepare. So here we have examples, and we start with example 1. And in our example, we are preparing a molar solution of sodium hydroxide. So to prepare a molar solution of sodium hydroxide, we need to know the molarity of the solution we are preparing. And for this case, we are going to use 0.1 molar sodium hydroxide solution. So this is the solution we are going to prepare, a 0.1 molar. That is the molarity. Then from there, we ask ourselves, what will be the volume? So for us, we are going to prepare 1 liter or 1000 centimeters cubed of the solution. So from there, the next step is to find the number of moles so that it can help us, or it will assist us to get the mass that we are going to use to prepare this solution. So with the molarity and volume, we are going to calculate the number of moles of sodium hydroxide that is going to be used. So sodium hydroxide is our solute. So now moles is calculated using the formula molarity times volume in liters. The molarity is 0.1 molar and the volume is 1 liter. So 0.1 times 1 will give us 0.1 moles. So the number of moles of the solute that we need to use is 0.1 moles. Next step is to calculate the mass, or to determine the mass, and we are going to find the mass using the molar mass. So this one, we saw as we were calculating the number of moles, that moles is given by mass over the molar mass. So now to get the mass, we are going to multiply moles times the molar mass. So let's first get the molar mass, that is the RFM of sodium hydroxide. So the relative formula mass of sodium hydroxide is given by sodium is 23, plus oxygen is 16 plus hydrogen is 1, and that one gives us a molar mass of 40 grams per mole. So now we have the number of moles, and we also have the relative formula mass, or what we are calling the molar mass. So to calculate the mass, we just multiply the moles times the molar mass. So that is 40 times 0.1 will give us 4 grams. So the mass of the solute needed to give us a molar solution of 0.1 molar will be 4 grams. So we are going to dissolve the mass in distilled water. So next step is dissolve the weighed mass, that is 4 grams, in distilled water in a 200 centimeters cubed beaker, and then stir to dissolve. So we add the mass in a beaker, that is a 200 centimeters cubed beaker, then add distilled water, stir until we dissolve all our solute. Okay, next step, we transfer the solution to a 1000 centimeters cubed, that is a 1 liter volumetric flask using a funnel. So we are going to use a funnel to avoid spilling. We want to ensure that it is accurate because we have measured accurately 4 grams. So we want to ensure all of it goes inside the volumetric flask. So we use a funnel to transfer the solution. Then we are going to rinse the beaker with distilled water, and then add the content in the beaker to the volumetric flask. Okay, that is step number 5. Then step number 6, which is the last step, is to dilute to the mark using distilled water to bring the solution volume to the mark. Then we ensure thorough mixing to obtain a homogeneous solution. So by doing or by following these 6 steps, we have already prepared a molar solution of sodium hydroxide, that is a 0.1 molar sodium hydroxide solution. Good, that is example 1. So we can look at another example, that is example number 2. Here we are asked to prepare a 250 ml solution of 0.2 molar hydrochloric acid. So we are given the molarity, that is 0.2, and we are given the volume as 250 ml. So step number 1 here is just to calculate the moles. So the number of moles using still the same formula, molarity times volume in liters. So we have 0.2 molar multiplied by 250 ml converted to a liter. So divide by 1000 to give us 0.05 moles. Now after we have the number of moles, we can calculate the mass because we know the molar mass of HCl, that is 1 for hydrogen and 35.5 for chlorine, giving us an RFM, or the molar mass, as 36.5 grams per mole. So this is the molar mass for hydrochloric acid. So now to get its mass, or the required mass, we take the number of moles, which is 0.05 moles, then multiply by the molar mass, which is 36.5. So this one will give us 1.825 grams. So this is the mass we are going to use, or we are going to dissolve to get our molar solution of hydrochloric acid. So step number 3 is to dissolve our mass in water. So after weighing 1.825 grams of hydrochloric acid, we dissolve it in a 100 centimeters cubed of distilled water in a beaker and stir. So we transfer our mass into a beaker, add a certain amount of water, that is distilled water, we can add a 100 centimeters cubed, then stir, then make sure the solution now is transferred. So this is step number 4. We transfer the solution to a 250 ml volumetric flask. So this one can be a 250 centimeters cubed volumetric flask. Then rinse the beaker with distilled water and also transfer the same content after rinsing to the volumetric flask. So that is very important to ensure that, and this is done to ensure that all the hydrochloric acid that could have been left in the beaker, it is also transferred to the volumetric flask. So we rinse again with the distilled water and then transfer the content to the volumetric flask. The last step there, we dilute up to the mark. So the mark now will be 250 centimeters cubed, and then ensure thorough mixing to obtain a homogeneous solution. So those are the steps that we follow to prepare a 250 ml of 0.2 molar hydrochloric acid. Okay, that was example 2. Let us look at example 3. In the last example, we are preparing 250 centimeters cubed solution of 1.0 molar potassium hydroxide. Again, the same procedure. We are given the molarity as 1.0 molar. The volume as 250 centimeters cubed. So that is what we should prepare. The first step, we find the number of moles by multiplying molarity times the volume in liters. So molarity 1.0 times volume, which is 250, make it to a liter and divide by 1000 to give us 0.25 moles. So with moles, we can find the mass. So the mass of the solute we are going to use, we take moles times the molar mass. So moles is 0.25. The molar mass of potassium hydroxide is 56 grams per mole. This one gives us a mass of 14 grams. So this is the mass we are going to use, or we are going to weigh in a balance. So weigh accurately 14 grams of potassium hydroxide and place it in a 250 centimeters cubed beaker. So we can even use a 200 or 100 centimeters cubed as long as we add distilled water and then start to dissolve the solute. Then transfer this solution to a 250 centimeters cubed volumetric flask. So the volumetric flask is what we should consider when we are measuring when we are given these volumes. So if we are to prepare a solution of 250 centimeters cubed, we cannot use a 100 centimeters cubed volumetric flask. We must use a 250 centimeters cubed, so that when we top to the mark, the volume of the solution will be exactly 250 centimeters cubed. Remember, this distilled water we are adding using a wash bottle. So we transfer the solution to a 250 centimeters cubed volumetric flask, then rinse the beaker with distilled water, then transfer the content into the volumetric flask. Then the last step, fill the volumetric flask up to the mark with distilled water using a water bottle. So again, we add distilled water, and then we can ensure that mixing the distilled water and the solution that was there, we mix them well. We can stir to ensure we come up with a homogeneous solution. So that will be our last example. when we are looking at these molar solutions. So that example will lead us to this question here. We are told to describe how a 500 centimeters cube of 0.5 molar of copper 2 sulfate can be prepared. So using the same procedure with the three examples, you can be able to prepare this solution. We are given the volume, the molarity, and we can also get the mass using the molar mass, where we have been given the mass for copper, sulfur, and oxygen. So make sure you can describe how you can prepare that molar solution. Okay, that marks the end of part 6. In our next lesson, we look at dilution. So make sure we meet in the next lesson as we look at dilution and what is dilution of solutions. So till next time, goodbye.